Alright, so today we are going to be talking about translating expressions. You may have done this before in some of your earlier math courses, but we're going to do a little review and then some practice. So, to start, we're going to organize some of these key words that we use when we translate expressions. And if you don't know what I mean when I say translate expressions, I mean translating from words to symbols, or you can either go, or you can, excuse me, you can even go the other way. So, product here means multiplication, so we're going to write product here. Sum is addition. Add is also addition. Difference is subtraction. Fractions can be represented like a number over another number. And this symbol really just means to divide, so we're going to write fraction down here. Plus, we use for addition. Minus, we use for subtraction. Times, we use for multiplication. Quotient is the answer we get when we divide two things. Subtract, we use, obviously, subtraction. Multiply, we're using multiplication. Fewer, we're going to use subtraction for that, and we'll talk a little bit more about that in class, but fewer means you're taking something away, okay? Divide, we're going to use division. Increase by, kind of the opposite of fewer. We're going to be adding something, so we're going to increase something. So, increase by, we're going to put with addition. Take away, we talked about this when we said fewer. So take away is subtraction. More than. We are increasing something. Ratio of. That is subtraction. Another way you can represent a fraction is you can also call this a ratio, or ratios can be using that colon, but for our sake we're going to stick with that division right there. So ratio of. Less than is going to go here with the subtraction. And then one that wasn't included in this list that I also want to include is less. And these two things are going to be different, and we'll talk about the difference between those later. Okay, I want to talk about different ways to write multiplication. You'll see it several different ways, and I want to talk about all the different ways. So you can have two numbers just right next to each other. If they're variables, they can be right next to each other. If you just had two numbers right next to each other like that, it would just be the number 37. But when we use letters, it's okay to put them just right next to each other with nothing between them. You can also use this circle, which we have developed that symbol later in our math courses. Also, parentheses are very important for multiplication. So you can have one with parentheses, or you can have both with parentheses. Number 5. We grew up probably learning it this way, but we're actually not going to use this way anymore. Okay, we're going to stick with the top 4. As for ways to write division, you can write it like the fraction sign that we were talking about in that last slide, or you can write it using the actual division symbol. Okay, so let's talk about how to actually translate algebraic expressions. So, step 1, we need to read for understanding. Obviously, it's important to read the problem so we know what's going on. Then we need to define the variable. In this case, a lot of our expressions are going to use the phrase number, so we'll just call it n for our case. Next, we want to translate the words into numbers, variables, and operations. So numbers, we know what those are. Variables would be the letters, and operations would be things like addition, subtraction, multiplication, division. You could also use things like squaring and square rooting. And then last, we want to write it as an expression. Okay, So 2 times a number plus 5. Let's read for understanding. So we have 2 times a number, and we have plus 5. Then we need to define the variable. Well, the only variable we need to define is a number, so we'll call that n. Then we need to translate. So if we're moving down here, 2 times would be 2, and then we have some times something. And in this case, we're multiplying it by a number, and then we're plus 5. Well, we know plus means subtraction, so we get plus 5. So then when we put it all together, we get 2 and plus 5. Alright, now 7 less than 3 times a number. So let's do the same thing. Read for understanding. So we have 7 less than 3 times, and then I'll put a number. Sorry, it's got a little squished. Alright, so 7 less than, not a variable, 3 times, not a variable. So this is the only thing that we need to define the variable. So we'll call this n again. And then let's take 7 less than and translate that. Here's the thing. 7 less than, because it says less than, we need to take 7 away from our other stuff. So we are subtracting 7. Okay? Then we have 3 times. So we're going to have 3 times something else. And then we'll just bring our n down. Well, because I said that this needs to be subtracting from something, we're going to take the 3n and we're going to write that first. Then we're going to subtract the 7 from that. Alright, now let's get a little more advanced. So, absolute value of the sum of a number and 5. So I'm going to write over here. So I'm going to abbreviate. Absolute value of, then I have sum of, and then I have a number and 5. So, the only variable I need to define is going to be n here. Okay? So then I need to translate. So if I translate absolute value, I'm going to have absolute value of, but we don't know what it's of yet. And then I have sum of, so I'm going to be adding something to something else. And then I have a number and 5. Well, in this case, the number and 5 are what we're taking the sum of. And then we're taking the absolute value of the entire sum. So we have n plus 5, but this is the something up here that we're taking the absolute value of. Alright, next one. Quotient of a number cubed and 12. So I've got quotient, I can spell, of a number cubed, and then I have n 12. So, the only variable that I need to define would be the number. And I'm going to translate. So quotient of means that I'm dividing something, but I don't know what those somethings are yet. Then I have a number cubed. Well, we've been talking about this in class. That means I'm taking a number and I'm raising it to the 3rd power. And then I have 12. Well, I know that I'm dividing something by something else, and in this case it lists this one first, and I'm dividing this. So I take my n cubed and divide by 12. And like we discussed earlier, I can also write this as n to the 3rd over 12. Alright, last one. So we have the square root of the product of 6 and a number squared. We've got a lot going on here, so we're going to break it up. I'm going to abbreviate so that I can fit it all. So I've got the square root of the product, I'm going to abbreviate this one too, product of, I've got 6, and then I've got a number squared. And this is a number, I'm sorry about that, y'all. Okay, so define the variable, so I've got n. And then I need to translate. So square root of, don't know what I'm taking yet. Then I've got product of, so I'm multiplying something times another something, got 6. And then I've got a number, but I can't forget about this squared. So a number squared is the same thing as a number a number to the second power. So when I put this all together, I know that I've got a product of something, and that's going to be my two things here. So I've got 6 times the square root, 6 times n squared. Jumping ahead. So then I need to take the square root of that something. Well, all I need to do is put it underneath the radical, and that is my final answer. So we have done a lot of practice, and we've used a lot of words. We'll use more practice in class, and we'll nail down just how to translate these, and we'll work on going from this back to words.